Element 26 on the periodic table is iron. Welcome to Norris Teaches Science with me, Mr. Norris. This is a physical science edition lecture video, and today we're going to talk about displacement, which means we're talking about more physics concepts. So your goal of the video is I can calculate displacements of an object based off a frame of reference. So what is frame of reference? Frame of reference is an object's motion and related to a fixed body or place. Now, what it means to be fixed is it's something not moving. So think about you in a car. You're in the back seat, you're looking out the window. What are you looking at? Well, you're probably looking at the trees. But it looks like the trees are moving past you. But the trees aren't moving. So you know that the car's moving. That's a frame of reference idea. Now, one of the more common frame of references is the Earth going around the sun, right? Or spinning on its axis. Now, what is displacement? Is the direction from the starting position, and it's a straight line distance between starting and ending. The thing about displacement, it has direction and distance. So what you're looking at here in this bottom picture, where I just placed the X, is a trail called the Nolan Trail. Back home where I'm from Virginia, there's a thing called the Nolan Trail, and it's a 10-mile trail. All right, you go 10 miles in the woods, it's like a 10-mile hike, but the start position and the end position are only about 500 feet from each other. So my distance I go when I would walk it is 10 miles. The displacement from this hike is only 500 feet. So that's the difference there because it's a straight line distance. Now we do combine displacement because displacement is something called a vector, and a vector is a quantity with magnitude and direction. It means it has a number and it has a direction like north, south, east, west, up, down, left, right. Now, how you combine vectors, we're just going to talk in the general sense here. If they're in the same direction, you're going to add them. So if there's two vectors and they're both going north, you can add their values together. If they're in opposite directions, you're going to subtract them and give the direction to the highest value direction. Okay. So we're going to do a couple examples here, just so you know. So combining displacement problem number 1. It says a ball was kicked east 10 meters and then was kicked east 5 meters. How far and in what direction is the ball from the starting position? So I like to kind of draw it out so I know what's going on. So we had the ball and it was kicked east 10 meters. And then the ball was then kicked east 5 meters. Well, you notice the direction is the same. So what you do, you take your values 10 and 5 and you add them together. So 10 plus 5 is 15 meters. Make sure you include the unit. And then you also still have to give the direction. And since they both were east, you would say east. And that would be the answer here for combining this displacement. All right, let's look at another problem. Okay, we're going to draw it as we read it. Sarah ran 20 meters north. So, north 20 meters from her house before turning around and ran 15 meters south. So, 15 meters south. How far and what direction is Sarah from her house? So we can see one is north and one is south, and they are opposites of each other because north and south are opposites and east and west are opposites. So we would take our two values, 20 minus 15, and we're going to subtract them because they're in opposite directions. So you get 5 meters. But displacement is a vector and you have to have a displacement with it. So to do that, we need to look. Was north higher than south, or was south higher than north? Well, north had a higher value, so it's 5 meters north of her house. And that's a little bit about combining displacement. It's really important that you know how to combine displacement when you start getting into, say, calculating speed, acceleration, force, all these other stuff that we're going to be calculating and using math in these videos with physics. I suggest every time you come back, you bring a calculator because I may make you do some on your own. But I hope you learned something today, and I'm Ms. Norris, and I'm out for this video.